Okay, good evening. Welcome. Thank you for attending. Hope all of you had a good first day. I'm Scott Pickett from TSRI, and I'll be speaking with you today about modernization, future-based modernization leveraging GenAI and Composite AI. So since the Stone Age, since the very first stone tools, there's been innovation. And the same holds true for systems today. What started out on mainframes and mini computers, leveraging languages, operating systems that are associated with COBOL, C, Fortran, and PL1, leveraging new technologies and Moore's Law, those have migrated onto personal systems, personal computer systems, networks, and data centers. With those new systems came new technologies, new operating systems, and new languages. Today, there's over 7 billion people that are on the network today, the internet today, through mobile devices and thin clients. Things are changing more rapidly than ever, yet you still see legacy systems like COBOL and mainframe systems that are in operation today conducting a number of different transactions. TSRI was founded on the principle of migrating people and systems from legacy mainframes, leveraging COBOL, mini computers, and even old client-server technologies into new cloud technologies, leveraging Java, C#, Python, and being able to do that in a way that will be able to support future refactorings leveraging GenAI. The company was founded out of Boeing AI Labs and really cut its teeth on its first transformation around the old Y2K updates, the Y2K modernization. Since then, the company's moved into over 250 different successful projects. And we just recently transformed over 17.5 million lines of code from source code to compiling code in 3 days. So this is a very mature technology. It's a model-based technology that is able to apply to many different vertical markets, effectively any vertical market. Whether it's healthcare, retail, financial, there's a lot of financial projects happening right now. Federal, we probably do about half of our business in the federal environment. Defense, whether it's embedded code, client server, as I mentioned, or mainframe, the same model-based approach and rules-based transformation is enabling people to migrate from legacy systems that are even 40 or 50 years old without SMEs available to modern systems in the cloud environment. Clay Christensen wrote a book called The Innovator's Dilemma that kind of depicts it well, where you see legacy systems, and it's been happening for years, eventually start to go into a sustaining mode. Eventually they stagnate, and then they obsolete. And what happens is the market leaders are threatened by new companies, fintech companies in the banking community, SaaS companies, and insurance companies. They start to emerge and take over that revenue stream. How people have been addressing it for years, or attempting to address it, is through manual rewrites. So market leaders are trying to go through and evolve their solutions to be modernized, to support modern languages, but it's not working. The reason why? Of the complexity associated with the legacies. There are specific encoding, whether it's EBCDIC, there's file formats, there's embedded in data that's in binary. There are VSAM files that people don't migrate readily to that are created out of the COBOL that are just underappreciated, not well understood for a standard developer in the Java environment. So most manual rewrites fail. Above 60%. There's dozens of reports and studies on this. Over 70% of the projects don't meet their requirements. 6% actually succeed. And the reason why? They don't have the SME knowledge, they don't have the institutional knowledge, and it's worse and worse over time as more and more COBOL programmers begin to retire. And they don't understand the technical debt associated with those systems. and how to replace those external interfaces, the OS systems, the sort functions, the embedded functions. They don't understand how to replace those in the new systems. How TSRI has approached this is with a deterministic AI toolset called JANUS. And get you in what really looks at an opportunity and a success rate that's very high because we drive towards functional equivalence very quickly. So the intent is to get it into a new language and get it functionally equivalent very quickly, minimizing the time that you have that risk and that technical debt. Get it to a place where it can replace your current system and from then on, be able to grow it forward. It's a rules-based approach, and that means you can adapt it to be able to support different refactorings. It's a high automation rate, like 99.99 automation rate, means that there aren't human errors injected into the transformation. So you have a reliable solution that has high fidelity between this old legacy source and the target languages. You're able to get it into a modern technology stack, whether it's going through a pipeline that leverages Jenkins, being able to support code quality refactorings like SonarQube, being able to support unit test requirements that can be generated automatically, being able to be put into a position where you're now going through a modern tech stack or a modern pipeline and be able to deploy into the cloud environment, either natively, supporting Docker's containers, or being in a position to support VMs. So you're in a situation now where you can have a baseline that's functionally equivalent that can replace your revenue, and you can build on that. Now, why don't you see the problems that you saw with the manual rewrite? You're able to get assets as a result of the transformation. You're able to have a functional test suite that can do regression against. So you know that if you innovate from there, you're not going to regress. You're able to provide documentation. You're able to provide blueprints, knowledge graph-based blueprints in the future, or now, and be able to get insight into your business and into your technical documentation that you didn't have before. So that's the next step of a composite AI solution. You leverage GenAI on top of a deterministic to be able to give you the ability to advance the projects forward. Be able to do that based on GenAI capabilities, leveraging the static analysis that was made available through the deterministic AI, and be able to move forward to meet your business requirements. And I'll talk a little bit about that as we move forward. Again, TSRI has built this over 30 years. This is a proven solution. We've done hundreds of different projects. We support over 30 different type of languages. Primarily, the biggest languages, most popular languages right now are in COBOL, PL1. Those are big, but we still get C, Fortran. We even do Java refactorings. The reason why is we migrate those into an intermediate object model that's language neutral. It still maintains a high fidelity with the target, but you can operate on it with rules. And those rules can be applied across multiple different projects, across multiple different builds, multiple different applications, and allow you to continue to build on a refactoring platform. You're able to extract blueprints, and you're able to get detailed information on the artifacts that are associated with the external interfaces that you need to replace in the target. Typically, we're meeting out into Java and C# and JavaScript and Python. But it's a solution that can be basically owned and moved forward with your IT department based on the latest as far as DevOps platforms and being able to deploy in multiple different environments. So JANUS, again, started with the Y2K, was built on over time. It has a grammar engine that allows you to be able to support multiple different types of languages, and it also has a transformation rules engine that allows you to refactor the code based on high-level rules. Those rules will allow you to do things like go-to elimination. It'll allow you to take similar code and consolidate it. It'll find dead code and you can eliminate it. It'll be able to do code quality refactorings, performance refactorings, be able to break out nested do loops that are very unperformant in cloud technologies, and then be able to go through a final phase where you actually get it into a target language that's deployed into your pipeline. We'll talk a bit about the pipeline here moving forward. But what TSRI is doing now is it's adding on to that new capabilities around testing. We're extracting out test metadata that has all the input files, all the database tables, all the external interfaces, any of the API interfaces that were in the legacy, align them up with the programs through this static analysis, and be able to give you unit test cases that are ready to run through automated orchestration scripts. In addition to that, we're building on additional data sets from the LLM. So you're getting a new asset as a part of your transformation project, a test asset. And on top of that, that's available for demonstration over in our booth 118, is the ability to run agents on top of all of the artifacts that we're making available on the documentation side. So you've got your new SME that's available for you to go through and ask questions and get details. Get the details on the business documentation. Get details on what's actually implemented and what your target should be. And these are all artifacts that are made available. Yes, you could get the 1,000-page printouts, but they're also available through these agents that we have available, both an application agent that you can understand the business capabilities with, and the code agent where you get details on the design. You can literally go over and ask the questions, how many files are required for this program, or how can I do scheduling with this program, and it'll give you the answer if that logic is inside that program. One of the things that you need in any transformation project is a executive level dashboard that gives you the details you need to know what is going on with every phase of the project. So you need that snapshot. Every program application that you're deploying, how much code it is, what your target dates are, when you're going to see it deployed, how far you are in parsing, how far are you in compiling, how far are you through the CI/CD pipeline? Do you have any SonarQube errors? Do you have any code security errors? Where are you at with respect to your test cases? And then when you get into the test cases, you want to be able to drill down on what's your coverage on those test cases. Well, at the method level, knowing exactly how many more test cases I need to develop in order to get to 70% or 60%, whatever your metrics are. And you look at your functional equivalence test. You got to know if it ran. You have to know if you did the comparisons correctly. You need to know if you haven't run or if you haven't executed correctly. You need to know if every byte, every symbol is the same as the legacy. And you need to know if you've run it or not. So all of these are captured in a dashboard. And you can see as you go through day by day, week by week, eventually you want it all green. They're all functionally equivalent. They all pass. They all exact same reports, the exact same files, the exact same data tables as you have on the legacy. You also need to be able to track your bugs, your issues. You need more than a burn down graph that shows you're closing more than you're opening. You need to know what the root cause is. You need to find out if it's your data, it's your test data, which often is the case. Is it the test setup? Is it the environment? Is it an external interface? Is it the sort type of external interface that's causing a problem? You need to understand your root causes. So you can get all the details presented at the executive level at a dashboard so you know where you're at. And you know you're real close. You track this day by day. You see these new applications coming online, passing tests, being deployed in production, and ready for doing your deployments in the cloud. So how does that look? You use an iterative approach. The big bang days are over. Too hard, too risky, too much effort. What you want to do is things incrementally. Martin Fowler first wrote about this like 20 years ago, the fig strangler approach. And he got the idea when he was on vacation in Australia about the strangler going around and wrapping the tree and eventually replacing the tree with all the physical structure, and the tree dies, and there you have a representation of the tree. So that's the analogous to this algorithm where you're taking portions of the mainframe and you're migrating it to the cloud. You're developing the interfaces to tie back to the rest of the mainframe while still taking advantage of some cloud-native services. So you end up doing one application at a time, doing the front-end application, doing one application one batch program suite. So taking a portion of the application, lowering the cost at each step, lowering the cost, lowering the risk, and growing the amount of functionality that's in the mainframe. Eventually, you get to the final spiral where the whole thing is operating in the cloud and you're seeing dramatic results. couple of case studies. TSRI did a very, very large application for the United States Air Force. It was nicknamed the Beast. This particular project had been they tried to do it manually a half dozen times and failed. They ended up getting a 90% TCO, total cost of ownership reduction, and it supports hundreds of thousands of users today. Another example with Pitney Bowes. First they went out and did the UK. This is a postal payment solution. First out they did UK and Ireland. Now they're in the United States. Interesting that this is a .NET Core solution that's migrating to AWS. The Education Test and Service Company. What they're doing is basically tests for students, up to 50 million tests annually. This transformation was done in less than 3 weeks, and we were rolling it out into actual live deployments in less than 9 months. HUD, there's a multiple applications that's doing $28 billion of grants and loans annually. Was broken down into 4 different application parts. Dramatic reduction in costs. The first initial annual savings was $8 million. I worked on this project. It did a whole bunch of different copybook consolidation. Turned out that they're replicating their COBOL programs over and over and over again. And there was a lot of waste there. We were able to do some consolidation around that to lower the solution and make it more nimble. Interesting here, here's a situation where you're going to Java and then they targeted AWS. We are now working with a very large insurance company, replacing some 27 different mainframes. They've successfully rolled out across the country. Again, they just took a portion of the application initially. Turned out the billing was moved initially. It's now going to be added on with the plan profile component. So again, they're doing additional incrementally, big chunks of the application, incrementally moving out, deploying across the country, lowering the cost, and increasing the ability to support new business initiatives moving forward. The big one that they're supporting is the ability to get off regional mainframes that are supporting specific plans to a single solution that's multi-tenanting and supporting multiple different plans. So this whole solution allows for the ability to fit into a modern DevOps pipeline, being able to support unit tests, functional tests, security scans, being able to deploy in containers into multiple different environments, and then providing technical feedback based on either, it could be issues, it could be new integrations, it could be SonarQube, and bringing that back into the solution for continued refactoring. In the end, you're doing business refactoring, and you're allowing the ability to leverage GenAI to be able to support new design patterns, new capability, new partitioning of the application to move forward. And we'll do this continuously with the new Java and C# capability as well. So I believe I'm just about out of time, but I want to end with what you want to do is put yourself in a position to leverage GenAI with a solution that has functional equivalence, that you know is rock solid, that you can deploy into, you can do regression tests on, and you can build on. This will expand your development pool and expand your ability to respond to business requirements because you can hire people that actually can support the application. You'll be able to migrate using best-of-class technology stacks. You'll be able to plug into the standard CI/CD pipelines that you have today. You'll be able to basically streamline and eliminate dead code, eliminate inefficiencies, and be able to scale up. You do both at the same time. And you'll be able to continue to innovate with GenAI. We've got a demo of the transformations, the blueprints, the knowledge graph, and the agents over there in our booth, TSRI's booth, on 118. I'd like you all to go over and take a look. If you can't do it right now, make sure you swing by before the end of the conference. Thank you all for your time. Appreciate your attendance. I know it was a long day, and thank you again.